Good day, Ma'am Fernandez. You are one of the researchers in the section BSEE 1B. Today, we will be presenting to you our research entitled Vertical Axis Wind/Water Turbine, Designing a Cost-Effective Dual-Purpose Renewable Energy. To clearly understand our presentation, we created this visual presentation that will help you understand on what our study is all about. Vertical axis wind turbines represents a unique form of power generating technology. Historically, they have been relegated to fulfilling a small niche market in commercially available wind turbines due to their yawless design. Current vertical axis wind turbines designs lag behind their horizontal axis wind turbine counterparts in terms of efficiency, as measured by their power coefficient. Vertical axis wind turbines have been developed over recent years with a number of large Darius type turbines being built in America and with the Musgrove turbine being tested in England. Both types of turbines are now well known in the field of wind energy research. The Philippines' current blackouts and associated energy supply and security challenges have already prompted multi-sectoral bipartisan calls for action to transform the country's energy system. The island nation also remains highly vulnerable to the impacts of climate change. In the last few years, as potential impacts become clear, climate action has become an important issue for energy supply, energy security, job creation, and post-pandemic essentials like cleaner air and a healthy planet. Investing in renewable energy now should be one of the country's priorities in order to alleviate several problems it faces. Energy is a requirement in our everyday lives as a way of improving human development, resulting in economic progress and productivity. Energy services are needed to meet basic human needs such as health, lighting, space comfort, mobility, and communication, as well as to function generating processes. However, the Philippines' growing energy needs alongside an increasing population led to the continual use of fossil fuel-based energy sources like coal, oil, and gas, which become problematic by creating several challenges like the depletion of fuel reserves, gas emissions, fuel price fluctuation, and other environmental concerns. Access to electricity has a big impact on the economic process of the country. According to the theory, access to electricity can improve socio-economic conditions in developing countries. In the same way, electricity has many important uses, not only for the ability to supply, but also for farming, as farmers can use machinery to ease their work in rural areas. Also, electricity can provide internet services within the area, which helps those students who continue their education during this pandemic. The objectives of the study is to design a cost-effective dual-purpose turbine to generate electricity. Specifically, this topic is aimed to develop a cost-effective dual-purpose turbine in order for the production to be relatively cheap while maintaining an effective result. To validate the efficiency of the turbine in terms of producing electricity, for the researchers to evaluate where the said research is feasible or not, and to analyze the contribution to the energy crisis of society. In this study, the researchers will use an experimental method, where the experimental method involves the manipulation of variables to establish a cause and effect relationship. The materials and equipment to be used are as follows: 5 gallons round water container for the making of rotor blades, PVC pipes, bearings, and wooden dowels for the shaft that will be connected to the generator, plastic containers, sealants, and adhesive for the housing of the motor and the circuitry, circuit board, wiring kit, electrical conduits to connect the battery to the generator, and will monitor the wattage, metal bars for the braces in order for the shaft to be stable. For our proposed data gathering, the researchers will collect the power output of the turbine by measuring the kilowatt-hour it produces in order for the researchers to evaluate if the said turbine can generate enough electricity to reach a 1.25 kilowatt per hour demand. For our proposed interpretation method, the researchers will utilize two-line graph. One will be in terms of wind speed versus power generation. The other will be in terms of stream flow versus power generation. In this method, the researchers can evaluate and assess the efficiency of the turbine. That's all. Thank you and God bless.